Hi everyone, welcome to day 4. We should be having our planners out and writing down that day 4 is the homework, or you can write that it is packet page 23 to 24. A reminder, tomorrow's class you need to have your own compass, so if you haven't gotten one yet, remind your parents to go out and get one tonight. Hopefully most people have them already. And we've got 3 warm-up questions. We're going to pause the video for 4 minutes for you to try these 3 questions, and then we'll go over them after that. You're putting these right in the Monday box on the second side of your warm-up. So again, we'll give you 4 minutes to do this. All right, the first one, our first slope is 4. The second slope is -1/4. Well, if you flip and negate 4 over 1, you get -1/4, so these would be perpendicular. And remember our shorthand symbol for perpendicular, it looks like an upside down capital T. So the tricky thing in number 2 is we always want to try and think of our slope as what number's in front of the x. Well, this second equation, we could also write it as 1/3 x minus 4. And then it's a little clearer that both slopes are 1/3. Well, we just need to double check our y-intercepts and make sure they're not the same, and they aren't in this case. So we would have that these are parallel. Remember the shorthand symbol for parallel, you see 2 little parallel lines. A lot of times when you write it, you do it with a little slant so it doesn't look like an 11, but when it's printed, often it's straight up and down. And our last one, this is an xy axis. X equals 2 should have points like 2, 1, 2, 2, 2, 3, 2, 4. So x equals 2 is going to be a vertical line, and y equals 9 is going to be a horizontal line. A horizontal and a vertical line are always perpendicular because they will form a right angle together. Moving over to your homework. So the first one, if you found your slope of points A and B, do a y minus a y over an x minus an x. Whichever y you started with, start with its x in the denominator. Always reduce your slope. That one reduced to 3/2. When we do a similar idea with the other one, remember to always be careful if your second thing is a negative, you'd have minus a minus. That one gave us 2. The slopes are not equal, so they cannot be parallel. Second one, we need to get y by itself in our y equals mx plus b form. So we'll subtract the 2x over, giving us 5y equals -2x minus 1. Then we need to divide all the terms by 5. We'll get y equals -2/5 x minus 1/5. Moving on to the second equation, all we have to do is divide everything by 10. The -4/10 will reduce to -2/5, and then the x, -20 over 10 will be -2. Notice we have the same slope. We've got to check our y-intercepts. They are different. So yes, we do have parallel lines because they're the same slope and different y-intercepts. If they happen to have same slope but the same y-intercept, that would just be the exact same line. So that would technically intersect everywhere. Number 3, we want to know if these are perpendicular. Do your y2 minus y1 over x2 minus x1. We get -3/2 when we reduce. For the other one, we get +2/3. Well, if you take your -3/2, if you change the sign and flipped it, you would get 2/3. So therefore, they are perpendicular, and we call those slopes negative reciprocals. Negative because the sign is negated or changed, and reciprocal meaning we flipped the fraction. This was very similar to what we did in class. We just take 2 points and find the slope on them. So you had the -4, 4, and the 3, -3. That slope gave you -1. On the other line, we had 6, 3. And then you had to pick another point that was nice. So you had one -1 there, the intersection point that you could use. And that gave us 4/5. our slopes were not negative reciprocals. If one was 4/5, we would have been looking for negative 5/4 for the other, so therefore they were not perpendicular. Here we have, like in the warm-up, a horizontal and a vertical line, which are always perpendicular. Y equals lines are horizontal, they cross through the y-axis. X equals lines are vertical, they'll always cross through the x-axis. We're given an original line here. If we get y by itself by subtracting 2x and then dividing by 3, we get negative 2/3 x plus 4. We want to know which one is perpendicular. So we can make a prediction. If we change our sign and flip our slope, our perpendicular slope would be equal to 3/2. So we're just going through trying to find which one is 3/2. In choice A, if you subtract the 2x over and divide by 3, you get negative 2/3 for the slope. That would be an example of one that's parallel, but that's not what we're looking for. If you move down to choice B, if you subtract the 6x over and divide by negative 4, we'd end up with 3/2 for our slope, which is what we were looking for, so it's choice B. All right, so today we're going to continue writing equations of parallel and perpendicular lines. And we're going to start on page 19. Have your calculators out if you would like them. So there'll be one question today where we're going to work with a midpoint. So if you have 2 points and you want to find the midpoint, all you do is you average the x's and average the y's. So when you average something, you add them and divide by how many there are. So you add the x's, divide by 2, add the y's, and divide by 2. So just to give you an example, let's say we had 5, 7, and we had 11, and let's say 4. So we would add the x's, 5 plus 11, and put it over 2, comma, because it's a point. We would add the y's, 7 plus 4, and put it over 2. Well, 5 and 11 is 16 over 2. 7 and 4 is 11 over 2. 16 divided by 2 would be 8. And then 11 over 2 doesn't divide evenly. So you could either leave it as 11 over 2, or you could also write that as 8 comma 5.5. So we'll see in one problem today, we'll have to do the midpoint. And just like if you had 2 quiz grades and you wanted to find the midpoint, you just average them together. Same thing when you want to find the midpoint of 2 points. Just average the x's, average the y's, and those averages become your new point. Now we've worked so far with point slope, or slope intercept form of a line, y equals mx plus b. And we'll continue to mainly use that. But I just want to show you there is one other form of a line equation that you do see in math, especially as you get into higher level math classes, and that is point slope form of a line. So we'll give you a moment to write that down, and then we'll show you an example of how we could write the equation with that. Let's say we knew our slope was 2/3, and we had a point of 5, negative 1. Well, the 3 things that you fill in are the y1, the m, and the x1. So we would start with y, and we'd do y minus our y value that we have, which is the negative 1. So we have y minus negative 1 equals our slope of 2/3, and then x minus the x value, which we have, which is 5. So because there's a minus in the formula, in the end, our x and y values will look like they have the different signs, because minus and minus will really be a plus. And the 5 looks like it's a minus, but that's just because of the formula. And that would be your point slope form. That would be your final answer if you decided to use that form. We'll only talk about that briefly this year. You'll probably talk about it a little bit in Algebra 2 next year. In pre-calc, you'll see it a little bit more prominently, and then in calculus, you tend to only use that form of lines. So moving down to the bottom, we're basically going to do a whole bunch of practice examples today, And then towards the end, we'll get some examples that are a little bit more complicated. So we want perpendicular to the given line, and we want it to contain our point. Well, notice they already have our equation in y equals mx plus b form. So that's great news. To find our perpendicular slope, I'm going to abbreviate it with our perpendicular sign and then m. We've got to change the sign and flip the fraction. So that'll give us negative 4/3. Well, we're using our y equals mx plus b. We'll fill in that negative 4/3 for m. And now our point here is an x comma y. We can just fill those in for y and x so we can find our value of b. So we're going to put 8 where y is. We'll have negative 4/3 times 12 plus b. So we'll next do the negative 4/3 times 12. You always have the option of putting that in your calculator, but let me just talk you through how you could do it in your head. When you multiply a fraction, you're really multiplying by the numerator and dividing by the denominator. Since multiplication and division can be done in either order based on PEMDAS, do the division first if it goes in nice. It'll make the numbers easier to do in your head. So if we do the 12 divided by 3, that would give us 4. And then 4 times the negative 4 would give us negative 16. So negative 4/3 times 12 is negative 16. If you didn't follow that explanation of how to do it in your head, again, you can always just do it in your calculator. We'll add the 16 over. That'll give us 24 for b. And to finish out, we just got to actually write our equation. So we'll have y equals negative 4/3 x plus 24. And that's our equation that's perpendicular to our original line and passes through the point that we wanted, 12, 8. We're going to do our same thing in part B. The one difference is we've got to do a little work at the start. We don't have our original equation in y equals mx plus b form. That's called our slope-intercept form. So let's work to make that happen first by subtracting the 3x over. We'll now have 2y equals negative 3x minus 6. We want to undo the multiplying by 2, so we'll divide everything by 2. That'll give us y equals, remember to get in the habit of putting your slope in front of the x, so we have negative 3/2 x and then minus 3. From this, we are ready to pick out our perpendicular slope. We'll change the sign and flip the fraction. So we're going to have a positive. When we flip it, we'll get 2/3. We'll use our y equals mx plus b again. And we know what our m is. So we're going to have y equals 2/3 x plus b. Note, this time we're using 3, 2 as our x and y. So we're going to put 2 where the y is and 3 where the x is. When you do 2/3 times 3, take the 3 and divide it by 3 to get 1. 1 times 2 gives you 2. So 2/3 of 3 is just 2. We'll get b by itself by subtracting the 2 over, and b is just 0. So we could write our answer as y equals 2/3 x and put a plus 0 on the end. If this was a free response question, which it is, that would be fine, that would be full credit. But adding 0 on the end doesn't do anything. So we could also write it as just y equals 2/3 x, and if it was a multiple choice question, you would definitely see it written without the plus 0 on the end. Moving on to the next one, we're going to do a similar idea, but we now want to do parallel as opposed to perpendicular. Parallel, we will use the same slope. Well, in this first one, we've got to do some work to get y by itself. I'm going to add the 10y over. So we'll have 6x plus 5 equals 10y. And we'll divide everything by 10. 6/10 will reduce to 3/5, and we'll have a half. And this is now in our y equals mx plus b form. If we want parallel, we want the same slope. So we're just going to use that 3/5 as our slope. Our x is -5 and our y is 3. And we'll fill those into our y equals mx plus b. So we'll start with y equals 3/5 x plus b. Now in that step, you could have subbed in x and y right then as well. I'm just going to do it in 2 steps, at least for this example still, while we're still getting the hang of it. So the y is 3. We'll have 3/5 times the x of -5, and then plus b. -5 divided by 5 is -1, times the 3 in the numerator will give us -3. If you're not comfortable with that, you can just punch it in the calculator. We'll add the 3 over to get 6 for b. And now for our final answer, we'll have y equals, our slope was 3/5, then x, and we have plus 6 for b. If we go to part B in question 2, we've got a special case. We've got y equals -1. Well, let's take a look at what y equals -1 looks like. Here's our x-axis, here's our y-axis, here's -1 on the y-axis, and that's just a horizontal line at y equals -1. Well, we want to pass through 3, -4. If we plot that quick, that point's right here. So a line parallel to y equals -1 that goes through that point would look just like this. Well, it's just another horizontal line. So the equation must be y equals some number. Well, you decide what number it should be equal to based on what the y values are for all the points on that line. You have points like 0, -4, 1, -4, 2, -4, and so on. So our equation would just be y equals -4. Moving on to number 3, we want to write equation of a line. Slope-intercept form is just our y equals mx plus b that we've been using. We want perpendicular. So we want to be thinking that we want to change the sign and then flip the fraction. We've got y equals x, and they tell us the point we want to go through. Well, our slope right here, we really have a 1 in front of the x. That's 1/1. If you change the sign and flip the fraction, you get -1/1. So our perpendicular slope is just -1, because -1 divided by 1 is -1. So when we do our y equals mx plus b, we're going to have y equals -1x plus b. Now, I wrote it as -1 just to make sure it's clear what we're subbing in, but -1x can also just be written as -x. That's the same thing. We're going to fill in our x and our y. So we'll have -1 equals negative, then the -2 plus b. Minus a minus is a positive, so we'll have -1 is equal to 2 plus b. We'll subtract the 2 over, and we get -3 is equal to b. To finish off, we'll write our equation. You can either write it as -1x minus 3, or again, -1 is just the same as saying negative in front of the x. So either of those two are fine. On a multiple choice question, they would probably have the bottom one of those two as your choice. Moving on to 4, we want perpendicular, so we're going to think negative reciprocal slope. to AB, and we want to pass through the midpoint. Well, first, let's find out what our current slope is. And we'll do that by doing, like we saw on the weekend's homework, y2 minus y1 over x2 minus x1. For y2, I'm going to start with 7 minus, and then I'll put negative 3 over. If I started with 7, I've got to start with 3 for the x's, minus 5. Well, minus a minus becomes a plus. 7 plus 3 is 10. 3 minus 5 is negative 2. And then 10 divided by 2 is negative 5. Well, we want the perpendicular slope. Right now, that's negative 5 over 1. If you change the sign and flip the fraction, you'll get positive 1/5. So 1/5 is the slope that we are going to use. Now, the other thing we need is for our point, we need the midpoint. So this is where we practice that formula at the beginning of the lesson. So our midpoint formula, you add your x's and divide by 2, then comma, because it's a point, add the y's and divide by 2. And that'll give you your midpoint. So for us, we're going to have 5 plus 3 when we add our x's and put it over 2, comma, negative 3 plus 7 and put it over 2. 5 plus 3 gives us 8 over 2. Negative 3 plus 7 gives us 4 over 2. And so we'll end up getting 4, 2 for our midpoint. From there, it's just like our other problems. We'll fill in our slope, our x, and our y. So we'll do y equals mx plus b. And I'm going to fill in all 3 of those right now. We'll put the 2 in for the y, the 1/5 in for the slope, and the 4 in for the x. We'll get 2 equals 4/5 plus b. And we've got to subtract the 4/5 over. Well, 2 is really 10/5. 10/5 minus 4/5 will give us 6/5 for b. So we're going to have y equals our slope of 1/5 in x plus the 6/5 for b. And that's our perpendicular line that will go through the midpoint. We'll give you a moment to read through question 5. So we've got a word problem here, but the main idea is this is the one planes equation. We want it to be parallel because we want them to not intersect, and it's got to pass through that point. So let's subtract the 4x over, and we'll get negative 2y equals minus 4x plus 10. We'll divide everything by negative 2. And we'll get y equals 2x minus 5. We wanted parallel, so the slope that we're going to use is that 2. And this is our x and y that we'll use. So we'll have negative 2 for our y equals 2 for our slope times the negative 1 for our x, and then plus b. 2 times negative 1 is negative 2 with a plus b. We'll add the 2 over, and we get 0 for b. So we could either write y equals 2x plus 0, or the more common thing that you'll see is just y equals 2x. And our last one for our lesson today, we want to be parallel to this given equation and passing through 1, negative 2. Well, notice y is not by itself. We've got to get y by itself so we can pick out the slope. So we'll start by subtracting the 1 over, and we'll get x equals negative 1, or x minus 1 is equal to 1/2 y. To get rid of the 1/2, you can do one of two things. You could divide by 2, or sorry, you can divide by a half, or dividing by a half, that's the same as multiplying everything by 2. So we're going to multiply everything by 2, and we'll get 2x minus 2 is just equal to y. So our slope, if we want parallel, is going to be 2. And we've got our x and our y here from our point in the question. So y equals mx plus b. We'll put in our y of negative 2 equals our slope of 2 times our x of 1, and we'll use that to solve for b. We'll have negative 2 equals 2 plus b. Subtract the 2 over, you get negative 4 equals b. But don't stop there, because we want to still write the equation. So y equals, we know our slope was 2, x, and then you got minus 4. So notice all these, your final answer should have a plain old x and plain old y in it, not numbers subbed in for plain old x and plain old y. We sub them in as part of the process so that we can find the b value. All right, that's it for this video. You got the day 4 homework, and be sure to bring a compass to next class. Have a great rest of your day.